Okay.
Okay.
Have you heard of digital twin?
No, sir. No.
No. Okay. It is nothing but nowadays the computers are so powerful, as you know. Uh, Whatever is happening in the field can be completely through virtual reality and augmented virtual reality. You can create everything in your computer. It is defined as a virtual representation of a physical asset enabled through data and simulators for real-time prediction, monitoring, control, and optimization of the asset for improved decision making throughout the life cycle of the asset and beyond. So this is called digital twin. Okay, how it works? I'll show. Yeah,
Physical representation is sorry, virtual representation is called digital twin, sir.
yeah, a virtual representation of the entire asset.
Mm.
So what is physically there in the field in Theni will be there physically as if you are seeing in Theni. It will be there in your computer.
Computer.
Okay,
Mm.
through lot of sensors and everything, it is being enabled with
Mm.
digital cameras and everything
Okay.
in real time. It is already implemented in most of the wind turbine companies. Even Renew
Okay.
has got a powerful system.
Okay.
Renew Power also has got a powerful system to monitor remotely wind farms from anywhere in India.
No, renewable?
Yeah, Renew Power also is having, I think.
Oh,
Yeah,
okay. Mm.
I'm aware because I am one of the juries for performance appraisal and awards for wind farms in India
Ah, ah, ah.
for CAA Green Business Council.
Okay.
This year also, fifth year, I am going to serve as jury,
Oh,
wind farm performance assessment. At
oh.
that time, best practices of all those wind farm developers, they will come. I think Renew
Oh,
Power is a regular award winner also in something or other.
okay. Okay, sir.
Some of the wind farms will keep winning awards. Okay.
Okay.
Uh, so so this is there. Uh, this is called digital twin. Let me just give you a brief introduction. You asked me in the morning what is CFD, right?
Yes, sir.
Okay. So physical reality offshore wind turbine is here. Okay.
Mm.
In the most modern computer, the the complete physical reality will be simulated inside the computer, three dimensional.
Mm.
Do you see here? Fluid structure, interaction, everything will be simulated. Okay,
Mm.
and as if it is in the field, you will be monitoring your wind turbine.
Mm.
Okay, so the information will get exchanged from field to computer, computer to field.
Mm.
It'll go through cloud. Okay, sorry.
Mm.
Information transfer design phase, decision support and operation control throughout the operation phase. Information
Mm.
transfer in operation phase for real-time dynamic optimization maintenance throughout the project lifecycle management. Provides realistic load histories in design phase for next generation wind turbines. So digital thread is only a fiber optic link or a cloud-based link, nothing else.
Okay.
Okay, these are all powerful computers, servers, which will be monitoring this. I think you might be aware, Siemens Gamesa here, Asia Pacific office in Red Hills in Chennai, they
Ah,
are monitoring wind turbines all over Asia Pacific.
there?
Oh yeah, all over area Asia Pacific wind turbines of
Ah.
Siemens Gamesa, they are monitoring
Oh.
from
Through
Ch-
this,
yeah
through this, sir?
From Red Hills. Yeah,
No, through this technology?
yeah. They are Siemens is the leader in this digital twins technology.
But why is the Siemens Gamesa machine we are not, Renew is not purchasing?
Because right now, due to some trouble with one of their machine, I think
They
they
are
stopped
purchasing. Ah,
going for Siemens. Yeah,
okay.
one of the machine. Of course, Siemens is. Uh, I mean, just keep it with you. It is for sale company.
Ah, ah,
Siemens Gamesa is for sale
same.
as a
Mm.
company as a whole.
Oh,
Somebody who is
including
willing,
the
because they are making a huge loss in some areas. Uh,
okay.
so companies are trying to come up, but still they are
Mm,
running the show.
okay.
But probably it is up to be taken over somebody soon. Okay,
Okay.
the best bidder will get it. Okay,
Okay.
right, because they took Gamesa like that, Siemens. Yeah,
Uh.
yeah, right. Then digital twin also can be given for blade. By how the digital twin works is like this: in manufacturing stage, a numerical model. Okay, in operating and monitoring stage, there are sensors which will give modeling. There is an imperfection identified in the field. Okay, that will come into the model which is digital, and analysis will be done. Numerical implementation of physical damages, how to rectify everything. Repair suggestions will go back to the field, and repair will be implemented, and it will be monitored. Virtual test, the only virtual test after repair, and then final virtual test is implemented, and current performance will be monitored. Like this, it is possible. Okay, now,
Okay.
and everything is done through big data analytics and cloud computing and Internet of Things (IoT).
Mm,
Okay, and if you have time, you can watch this video. Okay,
okay.
it'll a short video. It'll give you everything about digital twin. Okay, right. Then blade design stage also, you can get the entire blade design. How the blade is normally hollow; it is not solid. Okay, the layered carbon fibers will be used. A lot of design inaccuracies, everything. Blade maker completely, they can develop a complete system for the blade design stage itself. Okay, using digital twin, from drawing to from a factory, from during manufacturing, through digital cameras and other sensors, they will be able to continuously monitor the manufacturing, and even during fatigue testing, cyclic testing. You know what is fatigue, right?
Fatigue is
Fit,
fainting, no?
yeah, fatigue. Fatigue
No.
is one, that is if you want to break aluminum rod, let us say. Okay,
Uh,
uh, if you want to break it fast, you have to bend it fully 180 degrees up and down.
mm,
Okay, that means what you are doing is extreme tension and extreme compression you are giving to the fiber of the blade,
mm.
fiber of the rod. Then you can break the aluminum rod in 10 cycles. Okay, you can break the rod. Suppose you don't bend it 180 degrees, bend it only so much, it will go for 100 cycles. So in a dynamic situation in wind turbine, most of the parts, including tower, blade, and foundation rods, all of them will go cyclic, alternate tension compression reversal due to
Mm.
fluctuating loads.
Mm.
So that is called fatigue.
Okay.
Okay, and that has to be tested by blade testing, by oscillating the blade in different frequencies.
Oh, okay.
Okay, by oscillating the blade in different frequencies, it has to be tested.
Mm.
Okay, so all those things are required. All these inputs can be done in the digital twin nowadays.
Okay.
You can do simulation as well as really feel the components. Okay, this is about in general modern trends. Okay,
Mm.
how you use digital twins not only in design stage, including O&M and continuous monitoring.
Mm.
Okay, then generally the wind turbine components, especially the controller, is the heart. It is like the CPU of the wind turbine,
Mm.
uh, which you will know definitely in the electrical terms. Okay,
Yes, sir.
whether grid is it pumping energy to the grid or receiving energy from the grid. Everything you'll know. Okay.
Okay.
So controls large number of switches, hydraulic pumps and motors for which are used in the pitch control, yaw control, and more than 100 to 500 parameters will be monitored by the controller. Okay.
Okay.
And whatever details you want to effectively control your wind turbine, you can select in the SCADA and take that output with the permission of the SCADA administrator.
Okay.
And you can analyze. It'll have from wind speed, wind direction, power generated over the years, all the information it will be having. Okay. And it checks the rotational speed of the rotor, gear, generator, voltage, current, everything. Uh, and when it comes to foundation, uh, you normally this tower and foundation is a balance of plant. You normally give it to civil engineers.
Yeah.
Most probably, companies may outsource this by contracting, subcontracting, especially the installation commissioning. Okay. Uh, are you involved in any greenfield project now recently?
No, all are greenfield only executed by Renew.
Ah,
So I'll be in SCM, supply chain
a
only.
supply chain, that is,
Only
yeah,
electrical.
electrical part. Okay, supply chain management. Okay. Okay. This foundation installation normally, most of them are tubular, except a few, except the hybrid Suzlon
Mm.
towers. Okay. Towers can be also hybrid. It can be pre-stressed concrete. Yeah, Windworld or Enercon, they have pre-stressed concrete tower. Are you aware of it?
No, like
Yeah,
I
yeah,
hybrid I heard,
uh,
but normally concrete tower is being like designed, right, sir?
yeah.
But all installed.
Windworld is original Enercon. Okay,
Ah, yeah.
original Enercon, and they are the only people they were marketing concrete towers earlier in India. But you will not even see it is a concrete tower unless you go and go to the tower and tap it.
Oh,
It will be
but
so well.
why it is not being implemented, sir?
No, it will be so well finished.
Uh-huh.
You cannot make out it is a steel, concrete tower or a steel tower.
Okay.
Yeah, Enercon had it and Windworld continued it. Okay,
Why it is not being implemented nowadays?
it's being implemented in large towers. Okay, nowadays, I think Senvion is having a offer for concrete towers. Concrete towers, probably they are not because our people are more. There are more steel tower vendors. Okay, and concrete tower requires a solid foundation, and the tower can be precast concrete.
Mm.
Uh, you have seen this metro rail construction, right?
Yeah.
Uh, the girders are all pre-stressed concrete
Yeah, yeah.
girders.
Mm.
So what they do is they stretch a high tensile wire,
Mm.
okay, before concreting is poured, and then they allow the concrete to set, okay, and then release the tension in the wire, okay. That will create pre-compression in concrete, okay. That is called precast, pre-stressing, because concrete is weak in tension
Mm.
but very good, very strong in compression.
Mm.
What they do is they pre-compress the concrete, okay, so that it never goes into tensile stress during alternative stress reversals like tension compression.
Mm.
So that way the concrete tower will be rugged. You can change the machine without changing the tower.
Mm.
I think so. Slowly it will come up in the long run in India. Right now, it is not there. So foundation is erected first, tower, and then the nacelle, mechanical brakes, controllers inside, everything. Then wind vane and anemometer at the nacelle to give at what wind speed, what power it generated. This will be an input for SCADA data. Okay,
Okay. So
automatically.
2 minutes I'm cutting the video, so 2 minutes. But
Okay,
I'll be here only. Ah,
okay,
yes, sir, you can continue, sir.
right. Then anyway, I am not seeing the video because I'm in full screen.
Ah, okay, okay, okay,
No
sir.
problem, no problem.
Ah,
Okay, right. And this is the generator. Okay, and then direct drive gearless technology, which uses probably permanent magnet generator. Okay,
ah,
then rotor hub, then panel, then electrical yard, very well. Okay, then cable, all those things will have to come. The installation process is starting the foundation first, and then putting one by one, the assemble the nacelle, everything. That nacelle goes on top.
mm,
Okay, and all the control panels are taken to the substation, and there are about 8,000 number of parts in wind turbine. More
okay.
than about 8,000 parts are there in the wind turbine.
8,000.
Yeah.
Uh-huh.
Okay.
Mm,
Uh, so each one probably many times it will be acquired from different manufacturers.
okay,
But the designer of the wind turbine will know very clearly what to get from where. Okay.
okay.
Yeah. This slide we have seen, I think already.
Yes, sir.
Okay. Then uh, the rating of the wind turbines are keeping on increasing. Now, latest is 5.2 megawatt from Adani.
4.2 megawatt was machine, sir.
5.2.
No, 4.2.
4.2 is I think Senvion. I don't know. I think
Okay,
you
sir.
can see the latest RLM list.
We are using 3.3 only.
3.3
Envision.
only. So
Yeah, yeah, Envision.
this will be Envision, I think.
Envision, okay.
4.2 will be
But I
Envision.
don't think
Yeah,
4.2 Renew is not using.
yeah. And this is Adani, recently certified
Yeah, yeah.
by WindGuard.
Mm.
Yeah, WindGuard is Kumar Well, who was a former Neve scientist.
Oh,
Yeah, he was my former colleague.
okay, 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 okay,
He is
sir.
the country head in India, in Chennai.
Uh-huh.
Yeah, and the largest wind turbines in the world are 10 megawatt, and lot of many companies are there now. Uh, Sea Titan, Sway Turbine, and
Mm.
I think most of the wind turbines are offshore beyond 5 megawatts. Okay,
Okay. Mm.
uh, and because why large wind turbines are in offshore? Because uh, they can be manufactured in the coastal factories. Okay,
Mm.
and then they can have a floating barge. In that, any size of the component can be kept in the barge and taken to the site and installed.
Mm.
Whereas if you know the blade being carried by our highways,
Yeah.
it requires special permission, logistic arrangement, everything.
Yes, sir. Special
Uh,
vehicle.
yeah, vehicle. Some rural
Mm.
areas it will not go in.
Yeah. We
You have
have to do
to,
a certain.
yeah, you have to remove the electrical wires to transport some of the nacelles.
Mm.
So all these things will. These large wind turbines are slowly coming up in India. India is a
Okay.
big market for wind turbines. Okay,
Okay.
uh, right. Wind installations, of course, it's also growing, and I think this you must be knowing environmental impact.
Yeah.
Environmental impact assessment is not a must for onshore wind turbines as of now today. I don't know any
Yes.
new rules have come up
Okay.
for offshore wind turbines. It's a must. EIA,
Mm.
EIA assessment is a must. For
Sir,
offshore,
offshore is sitting in the sea, sir. Sitting on the sea, no, sir.
yeah, setting on the sea.
But onshore is like what we are using.
Yeah, what we are using, even in paddy fields, you can put onshore.
But nowadays the ESG, company is giving importance to ESG, so that way this will also have impact, no, sir.
Yeah. ESG is environmental social governance. Okay,
Okay,
that is how environmentally conscious your company is.
okay,
Okay, how you are looking after the social inclusion and social requirements.
okay,
How you are governing these two in your administration,
okay,
in your management.
okay,
Based on that, ESG index will be given to a company.
okay,
Okay, this environmental impact becomes a very important thing in that.
okay.
Yeah. Then in this we have to also take care of the, as of now, this International Electrotechnical Commission. You are aware, right? IEC 61400 series.
Yeah, yeah. Mm.
That is a classification. Indian wind turbines are being manufactured
Mm.
as per that standard. So it also stipulates permissible decibel levels for how loud is a wind turbine.
Okay,
So if you take a lawn mower, that is grass remover, it will be around 105 decibels. Okay, a
oh,
blender, a mixer blender, maybe 90 decibels. A vacuum cleaner standby in your house,
yeah,
okay, it may have 80 decibels. About 50 decibels, a mid-size window AC,
yeah.
and about 40 decibels, a refrigerator, some of the refrigerators.
Okay.
Okay, so the wind turbine decibels should be around 40 decibels maximum. Wind
Oh,
turbines in residential areas are placed no closer than 300 meters from the nearest house.
okay,
So this is a GE stipulation. GE, how low is
okay,
the, so the acoustic measurement must be done and it should be calibrated on
okay,
and off.
okay.
Noise impacts. Okay.
Mm.
So just to give a idea of the decibel chart. Okay. A jet aeroplane will have 150, 140 decibels. Pneumatic drill 130. Industrial noise about 110. Stereo music sometimes 100. Some houses. Inside a car about 90 or 80. Stereo
Okay.
music. If it is
Mm.
stereo music. Then office space or home space about 70, 60 decibel noise will be there. Wind
Mm.
turbine is about 50 to 40 in that area.
Mm.
A whisper maybe 30 or 20. Falling leaves maybe 10 or 20. 10, 20. It's a
Okay.
decibel chart. Just to give an idea. Okay.
Okay. Mm.
Right. Then I think let's skip a small wind turbine for the time being.
Yeah.
Uh, Offshore wind, I think it will give 20 to 30% more energy. Why?
Offshore, sir.
Uh, because the water surface is smooth
Okay.
and wind will be steady unless it is during cyclone or rough weather conditions.
Okay.
The wind flow will be streamlined,
Okay.
a steady smooth wind flow.
Mm.
So that means the wind turbine will not have fatigue too much. Too much fluctuation means fatigue will not come.
Ah, okay.
So the blade and tower will not be loaded in fatigue too much.
Mm.
But at the same time, corrosive environment, you have to protect your power electronics, tower, everything, which are
Mm.
steel or metal, from the corrosive environment.
Ah,
So those are the things. But the power capture will be quite efficient. So that's why 20 to 30% more energy you will get in offshore wind power. Are you
okay.
having any plan to go for offshore wind power in Renew? Any idea?
They started doing, but not much, sir. They were
Okay.
only working on the hybrid towers, sir.
Okay.
but no news about that.
Okay.
Mm.
Right.
But sir, in India,
Uh,
anybody has have installed started installing offshore?
no, they have just started in Tamil Nadu and Gujarat. They have started leasing per square per square kilometer land seabed leasing.
Okay.
They have just started. SECI has, I think, floated already. Whether the tender is out or not, I don't know. There's
Mm.
a proposal to float 5 gigawatt in Tamil Nadu and about 4 gigawatt in Gujarat. And
Okay.
year on year, they want to increase to 2 gigawatt per year.
Okay.
Uh, this is in the on the cards, but right now there are not many companies who will do venture into offshore wind power in Tamil Nadu or
Okay.
Gujarat.
Okay.
They will, if at all they get the leasing, they will do the preliminary feasibility report survey, seabed analysis, typical foundation design, feasibility, energy generation, all those calculations they might do.
Okay.
Uh, right. The disadvantages of offshore could be uh, the geological seas, sand waves, sea and wave currents, saline environment, installation maintenance problems. Okay,
Mm.
and these are all requiring special ships to install and commission. Okay,
Okay. Mm.
right now they are not there in India. We have to hire it. They are all huge charges per hour hiring.
Okay.
Yeah. Right. Then the challenges of storage options. I think it is a topic to, yet to be done. Pumped
Mm.
storage is one of the existing ones.
Mm.
Okay. Excess wind energy can be stored in compressed air or pumped storage, or in future it may be green hydrogen generation,
Ah.
or EV charging stations
Okay.
powered by renewables
Mm.
in future. Okay.
Yes, sir.
Yeah. Because whenever you are asked to back down, you can use
Mm.
it for EV charging, battery charging, or pumped storage plants,
Mm.
or you can use it for green hydrogen generation.
Mm.
These are future options.
Options.
Yeah. Okay. Then typically, uh, I just want to show you one of the one of the micrositing guidelines released by NIWE.
Okay.
Okay.